Hi everyone, Samar here and welcome back to GoDevOps. So until now we mostly used images made by others, but now we'll create our own images professionally. So in real project, companies build custom images for their applications. So you need to understand how to package apps, how to optimize their sizes, how to organize layers and prepare containers for production. And before we jump in, if you're following this series and want to keep learning about Podman, OpenShift, Linux, containerization, and automation, make sure to subscribe so you don't miss the next episode, and let's get started. So first, what exactly is a container file? So a container file is simply a file with instructions used to build the container image. So that's it. It's basically a recipe. You write instructions one by one and Podman execute them in order to create the final image. But there is something extremely important to understand here is that a container file is not executed all at once. Each instruction creates a new layer, and this changes everything because the image size, performance, cache, security, optimization, and other things all depend on those layers. So let me give you an analogy. Think about a container file like building a house. So the from instruction, this is the land. It is the starting point of everything. So if the land is bad, the whole house becomes problematic. The run instruction, this is the construction work. So installing packages, creating directories, configuring software, and you are building the inside of the house. The copy instruction, this is moving furniture into the house. So your application files, the source code, your script, and other things. The env instruction, this is configuration. So electricity, water, internet settings. So basically the environment configuration for the application. And finally, the image is the finished house, ready to be used to create containers. So during the whole episode, keep this mental model in mind because every instruction modifies the future image. Now let's go deeper. So what actually happens internally when Podman builds an image? So every instruction creates a layer, and a layer is basically a snapshot of changes, and Podman stack those layers together. So if I install, for example, packages, that becomes one layer. If I copy application files, I have a new layer. If I configure environment variables, a new layer again. And this is extremely important because container images use something called a layered file system. And this is one of the reasons why containers are fast and efficient because layers can be reused, cached, and shared between containers. Now let's understand why layers matter so much. So first, every layer increases image size. So if you create too many unnecessary layers, your image becomes heavier. Second, every instruction is an independent snapshot. So this means if one instruction changes, Podman may need to rebuild the following layers. And third, caching depends on layers, and this is super important for build performance. So for example, if your dependency layer does not change, Podman can reuse it from cache, which makes build much faster. But if your container file is badly structured, even a tiny code change may force Podman to rebuild everything. And this is exactly why professional container files are designed carefully. Now, another very important concept is the base image. So the base image defines the foundation of your future container, and the choice of the base image affects security, size, performance, available tools, and compatibility. So for example, some base images are very small but contain very few tools, so the size is smaller, and others are larger but easier to work with because we have more tools available. And the base image also determines things like which package manager exists, the file system structure, installed runtimes, and default users. So choosing the correct base image is not just a technical detail, it's really an architectural decision. So before we start building our images, let me quickly show you the project we'll be working with throughout this episode. So Containerfile Lab. And inside this directory, I already have two files prepared. So Ep.4, which contains our small Flask application, and the requirement file, which contains the application dependencies. So to keep the focus of this episode on container files and image building, I've already created these files in advance. So if you'd like to follow along or review the code later, you'll find everything used in this episode in the GitHub repository, linked in the description. Now that our application is ready, let's start building our first container image. So we will start creating our container file. So we will start with our very first line to define the base image with the from, and we will choose as an image Python 3.12. So our entire image starts from this base image, and next we will use a copy instruction. And this instruction here copies everything from my current directory into the container. And this is already our first bad practice because we are copying everything blindly. So we are not controlling what enters the image. Potentially, we can have temporary files, logs, Git directories, or unnecessary files, but here we copy everything. And next, we will use a run instruction to install packages inside the image with pipe install. Flask. And you need to remember that every run instruction creates a new layer. So this instruction becomes one file system snapshot. And then we add another run instruction. So we will run pipe install for our requirements file. So this is another layer, and now we already have multiple layers being created. And finally, we have our last command, cd app. So this is the command executed when the container starts. So here it changed the directory, then launched our application. And yes, this container file will work, but structurally this is not clean at all. Now let's build our image with Podman build. We put the name, I'll call it GoDevOps server, the bad version, and we will use our container file. So here we have our image being built layer by layer. So the Podman will read the container file instruction by instruction, and it will create our image. And finally, our image is created. So now let's run it with Podman run command. in the background, and we will use port mapping to see the result. And we will use our image, GoDevOps server, add version. And now we have the application is running inside the container. We will test it on the browser. So we will look for the localhost 8080. So localhost 8080. And here we have our page appearing. So technically everything works. The problem we currently have here are too many layers, no clear structure, duplicated logic, manual directory changes, and poor optimization. And this is exactly what happens in many real projects. So the application works, but the container file becomes difficult to maintain, harder to optimize, and inefficient over time. So now we're going to improve the structure of the image, not by changing the application itself, but by improving how we build our image. Important improvements are coming: work tier, improved copy usage, and combined run instructions, and each one solves a specific problem. So now let's modify our container file. So let's start with work tier. We'll add it here. So in the previous version, we were manually doing this with this command, so cd/app. And honestly, this is not clean. So we are manually changing directories inside commands, which means our container file has no real working structure. So instead, we define a working directory globally. And from this moment, all following in structure automatically executes inside /app. Then we'll need to change things. We no longer need this command. And the requirement, we remove this part. Now the container file is cleaner, simpler, and easier to read. Now another very important optimization is combining the run instructions. So remember that every run instruction creates a new layer. So in the previous version, we have created two separate layers. And in simple examples, this may not look important, but in large enterprise images, too many layers become inefficient. So instead, we can chain commands together. And now both commands execute in a single layer. And this reduces image complexity, but there is something important to understand is that reducing layers is good, but readability also matters. So in real production environment, you need to balance between optimization and maintainability. Now let's build it. So with the Podman build command, we use as a name the GoDevOps server, better version, and we use our container file, and we create our image. Now that the image is created, let's inspect the image layers with Podman image tree command, and we put the name of our image, server, better. So here we can actually visualize the layer structure, and now we should see less layers than before because we reduced the number of run instructions. So we can compare it to the version of before. So here we have more layers than before. Well, the difference is just one layer, but we can see the difference. So let's summarize what we improved. First, the structure is cleaner. Second, the container file is easier to read. Third, we reduced unnecessary layers. And fourth, we removed duplicated directory logic. So our container file is now better, but honestly, this is still not how we build real production container images. So right now, our image is still bigger than necessary, configuration is still weak, and we are missing important DevOps metadata. So in this part, we're going to transform this into something much closer to a real production-ready container image. So the first improvement is changing the base image to a smaller version. Smaller version means having less attack surface and faster deployments. So we will change the version 3.12 to 3.12 slim version. And this image will remove unnecessary tools and packages and only keeps what the application truly needs. The next improvement is adding the env instruction. So env allows us to define environment variables inside the container. So here we will add two environment variables. So the first one will be Flask and environment, so it's going to be a production environment. And then the second one is the app port. It's going to be 8080. And this is extremely important because we never want to hardcode configuration directly inside the application. Instead, we inject configuration through environment variables. And next we have the label instruction. So label will add metadata to the image. So here we will add 3 examples. So the first label will be for the maintainer, which is so we will put GoDevOps. We can add as a label the version of the. So our version is the first one, so 1.0. And we can also add as label the environment that we're using, so the production environment. And at first, label may look useless, but in enterprise environments, this becomes extremely important because DevOps platform, CI/CD pipelines, security scanners, and registries often read image metadata automatically. So, for example, they can look for who created the image, which version is deployed, which environment it belongs to, or which team owns it. So this is why metadata matters. And next we will use the expose instruction. Expose. And we will put the board. And a very important thing here is that expose does not open the boards. A lot of beginners misunderstood this. So expose and port mapping is different. Expose is for documentation. So it tells anyone reading the image that this application listens on this port, and the real port mapping still happens at the runtime. So with the Podman run command with the P option. And we will also change here the work directory. So we will put opt/app to define a clean working directory since we changed the base image. And we will only install the requirements needed for the runtime, so no need to install other things. And finally, the startup command for the container. So we have Python app compile, and now let's build the image with the Podman build command, and we will change the version. So it will be the best, and our container file. Now we wait for our image to be built. So now that we have our image, let's run it to have our container with the Podman run command. In the background, we add the port mapping, and we put our new image, the best version. So now we have our container. We can see if our container is working. Localhost 8080. So the application still works, even with all the modification that we have done to the container file. But now the container image itself is designed much more professionally. So the last version is the best version till now. All right, now we've reached something close to a real production container image, but in real DevOps environment, teams don't stop here, because production containers are not just about running an app. They are about build time flexibility, runtime safety, data persistence, and secure execution. Before we go into the terminal, we need to understand 4 important concepts that takes us one level higher in container designs. So the first one is the difference between arg and env. So this is one of the most important distinction in container builds. So first, arg, it's the build time variable. So it only exists during the image build process. For example, you can use arg to define versions, build options, or temporary values during image creation. And then we have env, and env is the runtime variable. So this is available when the container is running. So the key difference here is simple. Arg is used while building the image, and env is used while running the container. So in real system, we often combine both to pass values from the build time into the runtime. Next, we have volumes. So by default, containers are ephemeral. So this means if the container disappears, the data inside it disappears too. But in real application, we often need persistent data. For example, logs, database, or generated files. And this is where volume comes in. So a volume is a persistent storage outside the container. So instead of storing data inside the container layer, we store it outside on the host system. And this prevents data loss when containers are recreated. Now let's talk about security. So by default, many containers run as root, and that is dangerous in production environments. So if an attacker breaks the container and it runs as root, they can potentially access the system more easily. So we introduce the user instruction. It allows us to run the container as a non-root user. And this is one of the most important security best practices in container designs. Finally, we have the multi-stage builds. So instead of building everything in one image, we split the process into stages. So stage 1 to build the application, and stage 2 to keep only what is needed to run it. And this allows us to reduce the image size, to remove builds, tools, and improve security. And we will not go too deep here, but you will already see the patterns in the lab. Now let's build our most advanced container files so far. So first improvement is introducing a multi-stage build. So I will split the container into two phases, a build stage and a runtime stage. So here we will use this part for the run, and we will add a part for the build. So we use our Python 3.12 image as builder. The word here will be /build. We will copy requirements we will run a pipe install requirements. So the first stage, called the builder, is responsible for installing dependencies. It contains everything needed to prepare the application, including the pipe installation. So it keeps build tools out of the final image and reduce the image size, and also improve security, so we will have a less attack surface. So I defined the working directory inside the builder stage to keep the build files organized in /build to makes the build process predictable. And I copy only the requirement file first instead of copying the whole project. So this improves the layer caching if my code changed but dependencies don't. Podman will reuse the cached layer and skip reinstalling packages. And instead of installing dependencies directly into the system Python environment, I install them into a separate directory called /install. And this is better to keep dependencies isolated and to make it easy to copy only what we need into the final image. And now we switch to the second stage using our slim Python image, which will be my final production container. So this stage will not contain the build tools and will only have the runtime dependencies. Here we will add the arg instruction, which will allows me to pass a build time variable called app version. So it will be 1.0, and the arg will only exist during build, so it's not available at runtime unless it's converted to an env. And I will use the arg variable inside a label to dynamically tag the image version. So the version will be equal to the variable app version. So this will add metadata to image and helps tracking versions in registries. And now I will change the work directory back to up to be much simpler and to have a clean structure. So all application files will be centralized in this work directory. And then I will copy only the installed Python dependencies from the builder stage into the final image with the copy instruction from builder install lifecycle. So the final image does not contain pipe, compilers, or other things. It will only contain the runtime libraries that are transferred. So the image will be smaller, more secure, and will have a faster startup. And now I will copy the app.py, so only the application source code, into the runtime container. And this will keep the final image minimal and separate the code from the dependencies. We no longer need this line, so we will be removing it. And then we have to define a volume at /app/data to persist data outside the container lifecycle with the volume instruction. And this is important for the data to survive container deletion. And it's used for logs, for uploads, for database. And for security reason, I will switch the container to run as a non-root user called nobody. And this prevents privilege escalation and reduces the impact of vulnerability. And that's it. My container file is ready now to build our image. So now let's build the image with the Podman build command. We will call it GoDevOps server advanced version. And we will use our container file. And now that we have our image, we can run our container using this image. So let's summarize what changed in this version. So we have the build time separation using multistage. We have persistent storage using volumes, safer execution using user, and flexible configuration using env. Now let's connect everything we've done in this episode. So the first lab, we have created a bad image. The second lab, we have made a structure fix with adding the work tier and optimizing the run instructions. The third lab, we have made a production image by adding the env, label, and expose instructions. And the fourth lab, we had added advanced patterns like arg, volume, user, and the multi-stage build. So in the end, we have a production-ready container design. And now one important question is, how do we actually compare all of these images? To compare the 4 images, we can use the Podman images command. So here we have all images and their size, but we can make it clearer. Podman images format, and we choose which element to show. Here we have repository, the tag, and the size. So this allows to clearly compare the 4 images and their sizes. So we have the bad version that is extremely heavy, so at 1.15 gigabytes. So it installs dependencies inefficiently, splits package installation unnecessarily, and includes no optimization at all. The better image is still at 1.15 gigabytes, even though the structure is slightly improved, but it still installed dependencies in non-optimized way, and the image size remains unchanged because we used the same image as the first one. The best version drastically improves the performance, so it reduced the image size to 138 megabytes by cleaning up dependencies installation and using a more structured container file approach. And the huge difference is especially because of the change of the image used. And this is where optimization becomes visible. And the advanced version goes even further with a multi-stage build and a minimal runtime image. So we reduced the size to 128 megabytes, and this is the most optimized version in terms of structure, security, and efficiency. So this comparison shows an important DevOps principle. It is not enough to make an application work. What really matters is how efficiently it runs in production. So by improving our container design step by step, we achieve better performance, smaller images, faster deployments, and improved security. So this is the key takeaway. It's really not just about making something work. It's about making it efficient, secure, and maintainable. So to conclude this episode, a container image is not just a working application. It is a structured artifact, an optimized runtime package, and a secure delivery unit for production systems. And that's it for today's video. So in the next episode, we'll dive into volumes and see how containers handle real persistent data beyond their life cycle. And if you enjoyed this video and want to follow the rest of the series, don't forget to like the video, subscribe to the channel, and see you in the next one. Thank you.